Okay, you guys, here we go. Trigonometry. Now, trig is based on ratios of similar triangles. That's all it is. And you may remember this sort of catchy story. Some old hippie came hopping through our apartment. Or sometimes you see it written like this. Some old hippie came hopping through our apartment. And the idea here is that what we're trying to get at is that sine of some angle is the opposite over the hypotenuse, and the cosine of some angle is the ratio of the adjacent side over the hypotenuse, and that the tangent of whatever angle is the ratio of the opposite side over the adjacent side. So if we were to take a triangle, now always a right triangle, and let's say we've got one of our Pythagorean primitives, one of our maybe 3, 4, 5, right? And this is angle A, and this is angle B, and this is angle C. If I asked you to find the sine of angle A, what you would do is you would put your angle finding finger on A, angle A, and then you'd look at the side opposite A. 3 is opposite A, and the hypotenuse 5. If you wanted to find the cosine of A, you'd have your angle finding finger ready, put it on A, and the side adjacent to A is 4, and the hypotenuse is 5. If you're thinking the hypotenuse is also adjacent, think about it as being the adjacent leg. And then if you're looking at the tangent of A, you would say, no problem. The tangent is the opposite over the adjacent, 3 over 4. So that's our basic stuff. You probably remember that from geometry, but we're gonna remove it a little bit, make it a little bit harder, add some of the stuff we were doing last time with special right triangles. So let's say you have a triangle like this, and let's say I tell you that this is a 30-degree angle, and it's a right triangle. And maybe I tell you that the hypotenuse is 4. Could you find the sine, cosine, and tangent of angle A? Pause the video, see what you can do, and hit pause. Pause, 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 pause. And we're back. So if this is a 30-degree angle, we know this is a 60-degree angle. 90 adds up to 180. And we know that the side opposite the 90-degree angle is 4. Well, if we think about this as half an equilateral triangle, then the side opposite the 30 will be 2. And following our 30, 60, 90 pattern, we know x root 3, 2x. We know that the side opposite the 60 will be x root 3, or in this case, 2 root 3. And if you're not sure, you can do the Pythagorean theorem to prove it. Now, if we want to find the sine, cosine, and tangent of angle A, we're just going to use our angle relationship. So we put our angle finding finger on A, and sine 2 over 4. Oh, we got to reduce that. That's 1/2. The cosine is going to be adjacent over hypotenuse, 2 root 3 over 4, which reduces to root 3 over 2. Great. And the tangent opposite over adjacent is going to be 2 over 2 root 3. And our 2's are going to cancel out, and we're going to get 1 over root 3. But uh-oh, we've got to rationalize that. So I'm going to bring that down here, and I'm going to multiply that by a carefully chosen 1 Root 3 over root 3 is equal to 1. When I multiply it by 1 over root 3, I'm not changing the value of the fraction. But what happens is I get root 3 in the numerator and 3 in the denominator. So now my denominator is a rational number. And the tangent of A is equal to root 3 over 3. Ta-da, guys! We did it!